Welcome to our second statistics review video. Recall that in our first video we discussed an expected return, a variance, and a volatility of returns. And in this review we'll talk about covariance and correlation. Here's the first slide from our previous video where we talked about the terms random variable, observation, and sample. And recall that we talked about each one of these in the context of a single random variable, and that random variable was the stock return. And so let's label this stock return today as the return for stock A, and again recognize that we've got 6 realizations of the random variable, that is 6 observations, and they come together to form a sample. And we use that sample to calculate the mean, the variance, and the standard deviation. All right, so we're just going to build off of this sample and add observations from a second random variable, a second stock that we'll call stock B. And so here we go. And so once again, we've got 6 observations for stock A. These are the same exact return observations as we had before, and all we've done here is augment this sample with 6 observations from stock B. So we have 6 additional stock returns, and they are corresponding to each of the same years as the previous sample. And so our ideas about random variables they still hold. We just have 2 random variables now, stock A and stock B, and we still have 6 observations, but each observation now contains a return for both of the stocks. And so, for example, the 2017 observation has a stock A return realization and a stock B return realization. In other words, these 2 returns, the 2% for stock A and the minus 5% for stock B, those occurred at the same time. We're going to refer to this entire thing as the sample. And so there's just an extra dimension to the sample in this example. All right, and so instead of calculating a variance and standard deviation, here we're going to calculate some statistics that apply to pairs of random variables, and those statistics are the covariance and the correlation. Okay, so same as before then, we're going to take this sample and we're going to estimate these 2 statistics, and we'll use an Excel spreadsheet. Okay, let's go back to the spreadsheet we used to estimate the variance and the standard deviation in the first video, and I'll just walk through the variance steps real quickly. So recall, the variance in words is the average squared deviation from the mean. And so to calculate the variance, we first computed the mean. So we took the series of return observations, added them up, and divided them by 6. So that gave us the mean. Second, we went observation by observation and computed the deviations, and so the value of the return for a given year minus the mean, so those are the deviations from the mean. Third, we squared the deviations, so we took column C, squared it, and that gave us column D. Fourth, we summed the squared deviations to get this number, and then finally, fifth, we divided by n minus 1, which is going to give us something that looks like an average squared deviation from the mean. So that's the variance. Now let's tweak this spreadsheet just a little bit as a segue into the covariance calculation. And so I'm going to do this by rewriting the deviations real quickly. So the first thing I'm going to do is copy these columns over here and duplicate them. Okay, and so nothing's changed. We just repeated the columns. And so I'm going to label these over here stock A, and these stock A as well. So again, these return series are identical to one another. All right, so for the variance, remember we need to square the deviations. And so instead of literally squaring them, I'm going to say deviation times deviation. And so that cell is going to equal the first deviation times the second deviation. Copy that down. And to no one's surprise, this deviation times deviation column is going to look identical to the squared deviation column before. And so we can sum that column. And then divide by n minus 1. Get the same estimate as before for the variance. And take the square root. And we'll have the same estimate for the square root as before. So again, nothing's new here. I've just rewritten this just a bit where I've separated the columns. Now the term covariance refers to how two variables move at the same time. Do they move together, or do they move away from each other, or are they unrelated? And so the covariance calculation is based on the product of two deviations. And so we could say statistically, what we've actually calculated is the covariance between stock A and stock A, and that's this number. And since it's the covariance between one variable and itself, it's also known as a variance. Okay, so why do I go to all this trouble to set this up? Well, if we want the covariance between stock A and stock B, all we need to do is go back and insert as one of these variables the returns for stock B. And so I'm just going to go back to this column right here and replace stock A's variables with stock B's variables, and then we'll end up with, in our deviation times deviation column, just the product of the two deviations, right? So let's go grab the returns for stock B. So that's these returns here. So I'm going to copy those, and I'm going to insert them in here. And so notice our mean changed. So this is no longer stock A's mean. This is stock B's mean. The deviations have changed as well. And so it's stock B's return deviations from stock B's mean. And the product of the deviations has changed as well, right? It's now the product of A's deviation from its mean and B's deviation from its mean. And so that's what we get here. And so then we can add those in this column, and our sum is now the sum of these cross deviations. And so this is no longer the covariance between A and A, it's the covariance between A and B. And so there is our covariance. Okay, how can we interpret what we've done? Well, covariance is good, but it's not great. It's good because its sign means something. And so the covariance here is a positive number. And so what that means is that on average, when stock A's return is above its mean, stock B's return will be above its mean. And on average, when stock A's return is below its mean, stock B's return will be below its mean. And so these two stocks tend to move together. They tend to move in the same direction. So that's the nice thing about covariance, that sign is meaningful. The problem with covariance is that its magnitude doesn't really tell us anything at all. And so in order to get a little bit sharper understanding, we calculate the correlation, or the number rho that we described in our lectures. And so rho is always going to have the same sign as the covariance, but it will be bounded by -1 and 1. And so -1 is less than or equal to rho is less than or equal to 1. And so the closeness to 1 tells us the strength of this relationship. Now we calculate the correlation simply as the covariance divided by the product of the two standard deviations. And so I'm going to denote rho AB as the correlation between stocks A and B. It's going to be a function of the covariance between A and B, and so I'll call that sigma AB. We're going to divide it by the product of A's standard deviation and B's standard deviation. So that's the calculation. And so we just need all of these inputs in order to calculate rho. And so we need standard deviation for A and standard deviation for B. I've already calculated A, did that in a previous tab, and so I'll reference that cell. It's right here. And I just went back, and in that same sheet where I calculated A's standard deviation, I repeated the process for stock B, so we have that as well. And so here's B's standard deviation. So I'll put that there. And so the correlation, or rho, is just the covariance divided by the product of the two standard deviations. And we know this is going to be positive, okay? And this value of 0.76 is quite strong. You typically don't find two stocks that have this strong of a positive correlation. But the end of the day message is that A and B tend to move together, and the strength of that relationship is pretty high.